Hello, I'm Pablo Sebane, and I'm presenting my Module 12 Rocket Food Delivery. It's a REST API, a production-ready backend application that has been built with more enterprise technologies. Here we can see the technology pack that we are using for this project. We have different dependencies of Spring Boot and Spring Boot data. We're using Java 17 for the programming language. We're also using MySQL for relational database, Maven, which is a build tool and dependency management, Unit and mock MVC that are our testing framework. This project follows the model view controller architectural pattern, which I'll demonstrate by walking through the complete journey of implementing API endpoints from database schema to controller tests. Let me show you how all these pieces work together. First, let's start understanding the architecture of the project. Spring Boot organizes code into packages, logical grouping of related classes. I'm gonna expand here the architecture, and our main packages are, for example, models. So here in models, the entity classes are mapping the database tables using JPI annotations like add entity, add table, add column. It also defines relationships with add many to one or add one to many. We also have the repository that is the data access layer interfacing with the JPI repository. It contains the SQL queries using add query annotation. This is where the CRUD operations are defined, the create, read, update, and delete operations. Then we have here the DTOs. For example, this one. In the DTOs, this is the data transfer object. This defines the JSON structure for API requests and responses, separates internal models from external API contracts. Now we also have the controller with the API. The control layer is where the REST endpoints are using add REST controller and add request mapping. It handles the HTTP request, the get, post, put, and delete. It calls services or repositories and returns the response entity with status codes. Now let's move to the service. Here in service, is where the business logic resides. It contains the complex business rules, orchestrates multiple repository calls, and transaction management. And finally, here is our entry point, the Rocket Food application.java. This contains the method with add Spring Boot application, start the embedded Tomcat server, and initialize Spring context and dependency injection. So this is the flow from client to controller to service to repository to database and back through the layers. Now, let me show you this flow in action with a real endpoint. Now, before we start this endpoint journey, the get -API -orders as a step one, we'll start with the understanding of the model. So this entity is the first step to understand it. Understand the structure. We can see that we have different annotations here. The key concepts are here, for example, entity that tells the JPA this class maps to a database table. We have the table that specifies the table name, in this case orders. We also have an ID and a generated value that defines the primary key. We have the many to one annotation that defines a many to one relationship, which is in this case many orders belongs to one customer. We also have the join column annotation that specifies the foreign key column name in the database. In this case, we have many relationships with restaurant, customer, status, courier ID. So these annotations create the object relational mapping between the Java object and the database tables. Now let's look at the actual database schema that this model represents. We're going to go ahead and start with this step number 2, the database schema and relationships. So here on the screen we have the table orders structure in the Beaver, and we can show here the different columns. The ID is the primary key. Then we have other foreign keys such as customer ID, restaurant ID, courier ID, order status, status ID, and so on. Let me show you the diagram. Here we have also the table diagram. So these foreign keys are going to enforce the referential integrity. You can't create an order with a non-existent customer ID. So this is a junction table, the product orders. So I'm gonna show you this product orders table. It's also called a join table or bridge table that creates a many-to-many relationships between orders and products. One order can have many products. One product can be in many orders. We have different columns here as well. Order ID, product ID, product unit cost. This structure allows us to use the SQL joins to retrieve complete order information. Now, as a next step, let's go back to VS Code. We're going to show the repository file with SQL queries. Here I'm showing the order repository.java file. This is where we define our database queries. For example, in this annotation from the repository, order repository, we have this query over here that is calling all orders where customer ID equals customer ID order by descendant. List order, find order by customer in order by ID, ID descendant. So the key concepts here are the repository is a Spring annotation, marking this as a data access component that provides built-in CRUD methods such as find by ID. We have the add query that allows us to write a raw SQL instead of JPQL directly on the Beaver. We have this customer ID that is a name parameter in the SQL query. This parameter binds the method parameter to the SQL parameter. So this method signature defines that the return type, list order, returns multiple order objects. The method name, this one, describes what it does. The parameter customer ID is gonna filter the value, and this is what the Spring Data JPA automatically implements at runtime. The next step is to define the DTO, the JSON structure that the API will return. So in this API order DTO, we notice that data is the Lombok annotation generating getters, setters to string. We have builder that provides a builder pattern for object creation. We got fields. These become JSON properties in the response. And the nested DTO, for example, list API order product DTO for product array. This DTO flattens the database relationships into a client-friendly JSON format. Instead of nested objects, we include IDs and names directly. Now we're going to move to the controller where we handle the HTTP requests. So here we have the REST controller, which marks this as a REST API controller that combines a controller with a response body. We got the AutoWire dependency. This is a constructor injection that the Spring automatically provides the order repository instance. And continuing with the endpoint journey, here we have the business logic for the endpoint. Get mapping maps the HTTP GET request to this method. The request param extract query parameters from URL, and the response entity object is the wrapper for the HTTP response with the status code and body. So the controller validates parameters, calls the repository method, converts entities to DTOs, returns format response. So this is where the business logic resides: validation, orchestration, and error handling. Now we're in the test file, and before testing in Postman, I'll verify with an automated test. I'm gonna run this command. Okay, scanning. So the idea is that this file simulates the HTTP request without starting the server. That's what the mock does. But this integration actually hits the database, testing the entire stack: controller, repository, and database. For example, this AND aspect action assertions on responses. The perform post is going to simulate post request. And as you can see, the test run is a success. No failures, no errors. So now we're gonna test in Postman this endpoint. We have the terminal running, the app is running on Springbrook. And as you can see, it's a success. Tomcat has received the HTTP post. Spring MVC routed to order API controller, create order. The controller validated and called the repositories. Hibernate generated and execute the SQL insert statements. MySQL store the data. The response travel back through the layers with a JSON return to Postman. Notice that this structure over here matches our API order DTO exactly. which is this structure over here. This is the MVC pattern in action. Now, to finalize the testing summary, I'm running the test, the full test suite to verify everything. These tests are going to show that all CRUD operations, all validation scenarios, uh, all success and error cases, and the database interactions. So we are ensuring the production readiness. As you can see, the test run, 41 test runs has been success, and this demonstrates a professional backend. So to summarize, we have an understanding of the architecture, the MVC pattern with clear separation of concerns, the Spring Boot packages with models, repositories, controllers, DTOs, service, um, the entry point with Spring Boot application, database concepts, primary keys, foreign keys, SQL queries, select, insert, update, delete, CRUD operations, and the professional workflow, which is the model schema, repository DTO, controller, test, postman. We had the 41 passing integration tests and the production ready REST API. Thank you for watching.